Hi, I'm Rebecca Chicosky. I'm a master's student at the School of Biological Sciences at Illinois State University, and I work with Dr. Paul Garris. My research centers around how amphetamine affects dopamine neurons. So amphetamine is a psychostimulant, and it speeds up the messages the brain sends to the body, and it's used in prescription medication like Adderall for ADHD. However, amphetamine is highly addictive, and so even though we prescribe this medication, we know that it's addictive. And even 150 years after the creation of amphetamine, we don't really know how it works in the brain, and because of that, we can't sort out therapy from addiction. And the answer really lies through dopamine. So dopamine is the chemical that's driving us to learn. So when we take a drug, we learn that it's rewarding in the areas of our brain that help us to learn. And so one of the questions that we're asking in the lab is this even in that area of the brain? So if I look at a spot and I look to the right and the left, am I getting the same dopamine signals in response to amphetamine? In order to do that, I give rats drugs through an IV, and we use special sensors like this that we lower into that learning area of the brain, and they have multiple recording sites on them so we can look at multiple areas at the same time and really get at that question. And what we found so far is actually the brain isn't the same at all. When we look at an area just to the right or the left, we can have more, less, or about the same amount of dopamine when we give amphetamine. And this is really important because it's telling us that amphetamine isn't acting the same in our brain. If we can understand how dopamine is acting differently throughout the brain, we can then understand what amphetamine is doing as a whole when it affects dopamine neurons. And when we know that, we can then splice together or take apart that addiction aspect and make better, safer drugs, and so we don't have to worry about addiction hopefully one day.